Thank you for joining our webinar today about threats to cloud-based email. My name is Michael Landaway, co-founder of Avanan, and with me is Kip James, who has a long history of cybersecurity, starting with the United States Marine Corps, working through the U.S. Department of Interior, MPEG LA, Cendant, United Launch Alliance, GOI, and most recently ServiceSource. He advises CXOs in international privacy laws, ISO compliance, HIPAA, mobility, advanced malware, APT, and cloud. He has spent his life deep in the cybersecurity realm. And Kip, if you can join.
Hello, everyone. Thank you for joining the webinar. Pleasure to talk about a subject that's dear to my heart. What I'd like to first start out with is let's talk about the statistics of how information is stolen, or how does a hacker gain access to your environment. The biggest part is hacking. It's the most hidden way of going into a system is with stolen credentials. Once you have the user credentials, you pretty much have lost the war as far as making sure your infrastructure is protected. You know, today's hacking is not, in the past you used to have a system or a group of people that would do a front-end attack on your firewalls, trying to find your weaknesses within your infrastructure, and they don't focus on that today. The easiest way to get a hold of people are Instagram and Twitter and text. But 92% of the hacking attacks begin with an email, a very simple email. Of those emails, 13% of the companies are using cloud-based emails, and that's really important for our discussion today, as we're going to talk about how are those companies that are using cloud-based systems think that they're protected by using brand names. The two specific emails that we're going to talk about are Office 365 and Gmail. As you can see, that the companies are using these two main services. We just recently discovered last month or a couple of months ago that Office 365 had some serious malware, actually ransomware, that went through its infrastructure, and they actually do provide a threat-based analysis on email. But today we're going to show you those gaps. Security threats to the cloud based email are phishing, malware, and data leaks. Phishing is we're just going to send you an email and we're going to try to ask you some information or get you to redirect somewhere. They can deploy malware into the infrastructure via an attachment or redirect you to a malware site. Also, data leakage. How do you know where your information is going? There's a lot of data that's leaked out by email. The biggest thing that we see right now is the users. Actually, it's always been the users are always the weakest link in this chain here. So if you really look at what is your responsibility as a CISO or a security leader, is you're responsible for delivery, the users, and creating a policy and procedure that allows you to control how your infrastructure is used. Now, when you go into the email provider, they're going to look at the data, the app, the operating system, and network, and make sure that those things are secure as best as they possibly can make it. But where is malware really introduced? It's really at the user level. The users receive an email. You'll see in a statistic a little while later that 30% of the people click on an email. 30% of the messages right out of the gate are, people are going to click on them. They do that clicky thing, and then all of a sudden we have a mess that we have to deal with. 12% people decided they're going to click the attachment, or they're going to click the link. Now, not to make any light of this, is that some of the some security folks that I know wouldn't have been able to determine just by the view of that attachment, or the timing of that attachment, or anything, would they have been able to determine if that particular attachment contained malware. The link is a little bit easier, and you'll see later in the slide deck that where we focus on a link, when you hover over it, it gives you the actual link you're going to. And a lot of the things that you can refer to those is when you click, when it says click here. When a hacker is going after information, what is their biggest target? Their largest target by far are credentials. They're not looking, they're looking for secrets, but your credentials. So if I was a hacker, if I was a black hat hacker, and I wanted to get into your information unnoticed, I'm going to try to steal your credentials as much as possible. And that's what they end up doing. Here's another statistics is that the phishing sites, as you can see, there's phishing sites. Look at malware. Actually, look at malware and phishing sites. It is a huge increase over the last couple of years as far as the sites. They're looking to get into your information. Let's go ahead and look into how phishing works. So phishing is an attacker. It's an email link or an attachment. It's sent to a single person. There's a behavior that's once you click on that attachment or you click on the email link, it's actually it can install some malware. It's going to redirect you to a website for you to put in your credentials. And once it has your credentials, just imagine right now how many of your own personal accounts, and I know there are a few people on there, how many people use exactly the same password for all of their accounts. Now there are some industries out there, specifically Wells Fargo and First Bank, they actually use another point. If they do not recognize the computer, they're going to ask you to verify who you are. But there's a lot of installations that do not have a secondary mechanism or a two-factor authentication. So what happens is they steal your credentials, and all of a sudden they have access to all of your infrastructure if you're using the same password. On secondary accounts, it actually can do a direct install of malware, obviously putting backdoors, or it's going to export data. In some of my experiences that I've seen in a system, a large system that was compromised, is we actually watched command and control. We had someone take control of a PC, and we watched the data that they were exporting to another site. Also, look at payment systems, point of sale. How many skimmings have you seen with those? Not really using for credentials, but they actually have ways of getting that information from you. So you have to be observant when you're actually looking at all of these the malware that comes out today. So let me go ahead and show you what it would look like, on a redirection URL. So right now we have a screenshot that says a fake login page. I was just explaining to Michael this morning that I received a text on my cell phone that says, we need for you to verify your account on Citibank. And because I know that I don't really verify it, and I understand that how malware works and a lot of things that happen, we were redirected to a site, as in this picture here, and it asks for my credentials. It says, please put in your account name and then put in your password. It was very interesting to actually see that it seemed like it came from a valid source, but when you really look into the email, it's not the right location where you should be. This is the same in the recent DNC attack. This is how they got someone's credentials. Individual created a email link, and this is actually this is close to the link that I received on my cell phone. When it went from the email, it was base64 encoded URL, so no matter how much you wanted to look at the URL, you couldn't decipher it anyway. Someone clicked on the URL, they actually put in their password, because in the DNC they have username or they have the usernames, very common phrases. They just kind of put it up there and do a little bit of reconnaissance. Found out that Tom.Smith was there, so they created a user account, says please put in your credentials to log in. At that point, it can redirect you to the valid site to make sure that you're into the site, and it'll just pass your credentials through. Here's just a statistics slide that we have. As far as you can see, that malware factories are actually increasing year upon year. It looks like year 2014 was quite a jump as far as malware. So it's, malware hashes are only seen for 58 seconds or less. I mean, how are you going to protect yourself against that? This is just a display of how malware factories work. It goes through, someone creates it, creates a malware package. It actually sends it out, and it goes through Google Mail and Office 365. So let's go ahead and go a little bit further as far as where this goes. It's a benign script. Someone click. In this case, it's a Word document. It had a macro that was inside the file. It went out there. It went out towards a bad URL. Downloaded the malware. Malware installed into the system. At that point, you've been had. Now, you can block an executable from coming through email, but how many people on the call today block any executable coming from the internet into your infrastructure? Well, let me go ahead and turn it over to Michael to talk a little bit about what are the options within Office 365 that are available.
Thanks, Kip. And I think after looking at the different attack vectors, obviously the cloud providers, they have basic security, but the problem is that they don't offer the advanced security necessary to actually address those attacks. Now, recently, Microsoft has started offering its advanced threat protection, but it's not included in the enterprise accounts that most people sign up for. It is available and it is included in the more expensive account. And it does provide some of the levels of protection that you would want to have around your email. It has a number of antivirus engines. In fact, has its own detonation chamber, sort of its own sandboxing tool for suspicious attachments, for Office documents, PDFs, some flash files, and so on. And what we found is a couple of things. One, very few companies are actually using this system, either deploying it all or deploying it in block mode, because of that sandboxing, it results in a delivery delay of 5 to 30 minutes for each email. What that means is that any email with an attachment won't show up in the user's inbox for 10, 20 minutes. So you'll have that cycle of someone saying, I sent it to you, I'll send it to you again. I don't see it, I'll send it to you again. Because of that delay, most people are not actually turning it on. But more importantly, what we found is that it's actually not as effective as it should be. And there's actually a very simple reason why. Traditionally, malware writers have always tested their malware against Microsoft's OS defenses as well as the desktop defenses. More recently, however, with the growth of Office 365 and Google Gmail, a lot of attackers are now writing their software specifically for the cloud-based email providers, and essentially they send an email to themselves and they even test the advanced threat protection. So what we found is that because of Microsoft's popularity, that advanced threat protection is not as effective as we would hope it would be. So given those attack vectors, and given the strengths of the built-in security, what I'd like to do is take a look at some of the solutions that Avanan has put together in order to provide cloud-based security. Just a brief introduction for those that haven't met us. Avanan is a cloud security platform. We provide security for any cloud. In this case, we're talking about just Office and Microsoft and Google, but more important in this discussion is that we provide any security. We have partnered with over 60 of the major security vendors, provide malware protection, data leakage prevention, encryption, file standardization, endpoint compliance, and so on. And in today's discussion, we are just going to talk about Office 365 and Google Mail and only those security packages that provide email protection. So in brief, we partnered with these security companies to provide cloud-based versions of their security tools. For data leakage prevention, malware protection, anti-phishing, we take their data center software or their endpoint software and create cloud-based versions and then connect them via our platform to the cloud-based email. We are completely out of band, so your users connect directly to the cloud-based email. There's no latency, no delay, and even when we're using an advanced malware protection tool, sandboxing tool, because we're out of band, we don't have that sandboxing delay that might be inherent in Microsoft's advanced threat protection. So I want to talk about defense in depth and why having those multiple tools is valuable. Once email moved out of the data center, it lost the protection of the gateway stack and the different gateway tools that you put into place to provide full stack security. In the cloud, there's essentially one layer of security, and that is the security provided by Google or Microsoft. And what we've just seen is that that layer of security might be compromised by design. Defense in depth can mean multiple layers of security, but also multiple technologies within a particular layer. So let's talk about just malware. Today, there are three types of malware security. There's the traditional signature-based antivirus that we're very, very familiar with and we've had for decades. There's the new sandboxing technology that has become more and more important in recent years because the malware writers can write against the signature-based tools. With the sandboxing, we can actually test it and see if it detonates. And just in the last year or two, we've seen a growth of artificial intelligence predictive malware detection that actually uses a completely different methodology. Now, we in the security industry know that there is no such thing as a 100% solution, that each of these, even the most advanced, will have some holes. But more importantly, and this is where defense in depth comes in, each, because they use a different technology, will have a different weakness. And using them in series allows us to provide that full protection that any single technology would not be able to provide. In one example, phishing. We're able to analyze each email, follow URLs, see if they lead to malware or see if they lead to suspicious URLs. And while the user may see the funny cats URL, we can tell that it actually leads someplace else. And then, if we determine it's necessary, we will redirect those emails so that through our site so that we can actually test them as the user clicks on them. So looking at the platform itself, this is actually the quickest way to understand what we do. We connect to all the major SaaS and offer all the major security tools from antivirus, anti-phishing, malware sandboxing, and predictive malware. And from here, what I'd like to do is open up an actual interface and demo the email protection live. So the first thing I'm going to do is open up the interface so we can actually see the tool itself. So we can see here we're connected to a demo system, and we have a full security stack of different signature-based systems, as well as some sandboxing systems from Checkpoint and Palo Alto, and then AI system from Silence, as well as a couple of DLP and phishing solutions. So this is full stack security for our demo account. Now, as we look through, in fact, let me show you actually the tools that we are protecting. So I'm going to actually open up two accounts. These are Microsoft accounts, The one on the left, which is red, is an unprotected Microsoft account. On the right is one that's protected by the appliance that I just opened up using that full stack security. What I'm going to do is send an email to both and show you what it looks like from the user's point of view. I'm going to do that via a Gmail account. And in fact, just to make it much more fun, I'm going to use a set of malware that was just recently downloaded from a site that actually keeps track of recent malware. These are pieces of malware that were discovered here just today, a couple days ago, and so on. I went ahead and downloaded a few doc files, downloaded a few Excel files, and so on. And what I'm going to do is create a new email. I'm going to send it both to the unprotected as well as the protected accounts. And I'm going to do exactly what a malware sender would do. I'm going to go ahead and run a test. I'm actually going to try, I've taken these files and actually renamed them, but I'm actually going to try sending a few of them just to see what happens. So if I select on 3 or 4 of them and send them, what's happening now is Google is actually testing them before I send them. And looks like a couple of them got through, and it actually discovered one of them to be a virus. So what I've done is actually exactly what a malware writer will do, is create different versions of their malware and test it against, in this case, Google, in other cases against Microsoft. In fact, what I'm going to do now is actually remove those that it discovered, and I'm going to actually just send one for the sake of the demo. So I'm going to send this to both and ask the person to open it, just like a malware writer would. So what I've done now is sent this to both addresses. So what's happening now is that it's going out from Google. Here it arrived in this one. Now, this actually is a copy of the server attack. It's actually an invoice. I'm not going to open it, but I think the first thing you notice is that this account, which, by the way, is using Microsoft's Advanced Threat Protection, that's the full suite of signature-based tools as well as the sandboxing tool, but it made it through both systems actually very quickly. Now, we look on the protected side. This is another Outlook account. It has exactly the same Microsoft protections, but it also has the benefit of Avanan's protection. And what we can see here is that instead of seeing the document, it's actually, what we've done is replaced it with a text file that tells the user that it's currently being scanned. And if we click on it, it's just a text file to tell the user this is the file that will be available very shortly. And we can actually see that it was determined to be bad and the attachment was quarantined. So one of the benefits here is that first, the email showed up right away in the user's inbox. There was none of that 10, 20, 30-minute delay waiting for the test to happen. But I think most importantly to everyone is the fact that instead of allowing that malware to get through, it was quarantined by one of the many systems used to test files. One of the reasons why this file got through is because the server was actually known for being tested against Microsoft. And while they did add some protections, we've found versions that are still getting through. So let's take a look to see what it looks like from the administrator's point of view. We'll go to the dashboard, and we can see here that in the alert system, the Office 365 email found the server invoice that I sent. And if I drill down into that, we can actually see what happened. First, we can see that the signature-based systems, OnLog, Kaspersky, Checkpoint, they actually found that document to be okay, which is very possible because server was designed to be very dynamic and not found by the security-based systems. Now, the predictive malware system actually found this to be suspicious. It actually did not deem it okay and worthy of further testing. And then most importantly is that Checkpoint, the cloud-based sandboxing, was able to determine that it was bad. So in the end, the benefit of Avanan system is the fact that we have not a tool that we created, but multiple tools created by multiple companies, all with the latest and greatest technology to prevent malware, not only cloud-based email, but across all of your cloud, be it file sharing, your database systems like Salesforce, and communication systems like Slack. In summary, we've seen the attacks that are possible via cloud-based email. We've seen the solution that Avanan provides. If you would like your own personal demo, you can request via info@avanan.com, or we offer a 30-day trial not only of our platform, but all of the tools that we provide. You can sign up for that at avanan.com/trial. So, Kip, I'd like to thank you for joining us, and everyone that's online, thank you for taking your time. Have a great afternoon.
Thanks for the invite.